Hello, everyone. Welcome to this live webinar for SGS. I'm Dionysis Theodosis. I'm the Global Technical Development Manager within SGS. And I'm very happy to have with us Dr. Avi Abraham to discuss a particular topic that's had a lot of publicity the last years, and that's all about ethylene oxide. We know that the area of pesticides is very complicated, and there's a lot of regulations and a lot of requirements that we need to go through. And ethylene oxide, again, a lot of publicity a few months ago with several food recalls in Europe, and Dr. Abraham will be able to give some information on that. Hi, Abraham. Could you please introduce yourself and to the audience?
Good morning, good afternoon, good evening to everyone. I'm Dr. Avi Abraham, Head of Health and Nutrition Labs at SGS India.
Thank you for joining us. So I already mentioned that ethylene oxide got a bit of publicity the last 10 months or so. Would you be able to give a bit more background of the incidents and how did this occur?
Yeah, the first notification on ethylene oxide detection came from Belgium in September 2020, when a sesame seed consignment from India was detected for ethylene oxide at 186 ppm. Now, following this, then there were voluntary checks by various companies on products where they've used sesame seeds, and this resulted in many product recalls. Then, subsequent to this, other consignments of sesame seeds were being tested when it comes to Europe, and it was being found that ethylene oxide residues are present. Subsequent to that, this was found in not only sesame seeds, but in bakery and confectionery products where sesame seeds has been used. Then later on in vegetables like okra, then spices and condiments, turmeric, dried ginger. So the list increased, and perhaps I think almost till date around close to 700 product recalls are there due to ethylene oxide.
Okay, and you already mentioned that actually the range of products that you can find keeps getting wider and wider. So ethylene oxide is actually quite widely used. Why is a concern, and why is considered to be harmful?
Okay. Now, ethylene oxide, it's organic gas. It's an organic gas, and it's actually the raw material that is being used for making ethylene glycol. Now, this has antibacterial, then antifungal, antiviral properties. That means it can kill these microbes. And because of this, this has been used as a sterilizing agent, fumigating, and as a sterilizing agent. Surgical devices get sterilized using ethylene oxide. Then it was also used in for inhibiting the growth of salmonella in sesame seeds. That is when the use started in sesame seeds. And it's also used for fumigating spices, condiments, herbs, and so on. Now, the problem with ethylene oxide is that it's a known carcinogen. It has carcinogenic properties, yeah. Cytotoxic, mutagenic properties. So that is the risk that is associated in having ethylene oxide residues in products.
It is in the interest of public safety. When you read a lot about detection for ethylene oxide, many times also you read obviously about 2-chloroethanol, and potentially that can cause a bit of confusion for people that are not very much in the analytical science. Would you be able to briefly explain the relationship between the two chemicals?
Yeah, sure. Now, ethylene oxide, as I mentioned before, that's the fumigant, and once a product is fumigated with ethylene oxide, it needs to be aerated for at least 24 hours so that the residues of ethylene oxide gets removed. Mm-hmm. But however, if that aeration is inadequate or sometimes it's not effective enough, the ethylene oxide residues will react with the chloride ions that are naturally present in the product, and then a more toxic compound called 2-chloroethanol is produced.
Mm-hmm. Okay, so it's really kind of a byproduct, a natural chemical reaction. You mentioned already the public safety and health concerns. So as a result, several countries have established strict regulatory limits. Would you be able briefly to give us a kind of indication of the regulatory background requirements to primarily Europe or US?
Right. In Europe, the European EU Commission Regulation 2015/868 clearly mentions about the MRLs of ethylene oxide in various products. So from, say, in the case of oil seeds, it is 0.05. Then in the case of herbs and spices, 0.02. Then in the case of some spices products, it is 0.1 ppm. So all these are in ppm. So the MRLs, if you see that regulation ranges from 0.02 milligram per kg to 0.1 milligram per kg.
So obviously there is a connection between the type of commodity and also you need to be aware of the countries of destination where the product needs to be consumed to make sure that you comply with local regulatory limits. I guess from an analytical perspective, you need to make sure that your method covers all these different limits. So ideally, you would go for the most sensitive type of equipment or detection in order to be able to comply, not only now, but for possible future changes. What sort of instrumentation do you use for detection in your laboratories in India?
Right. Now, before I go into what type of instrumentation we use, I just like to mention first on the previous question that you asked about the MRLs, and you had mentioned about the US MRLs also. So in USA, they have, US and Canada, they have different MRLs for ethylene oxide and 2-chloroethanol. So for ethylene oxide, it's 7 ppm. And for 2-chloroethanol, it's something around close to 940 milligram per kg. So there's a difference. Whereas in the case of the EU regulation for both ethylene oxide and 2-chloroethanol combined, it ranges from 0.022 to 0.1 milligram per kg. Now, coming to the analytical part, if you want to detect only ethylene oxide, because ethylene oxide is a gas, it's a volatile compound, you can use a GC FID with a headspace. But as I mentioned previously, ethylene oxide does not remain as ethylene oxide in the product because naturally it gets converted into 2-chloroethanol. And this 2-chloroethanol, it's not volatile. So you cannot estimate 2-chloroethanol using a GC FID with a headspace. So you will have to use a more sensitive instrument. So we use the GC MS for detecting ethylene oxide and 2-chloroethanol.
Okay, so you're using this instrumentation. I presume the specific requirements you need to comply to make sure that your results are accurate and they can be trusted. Two questions from my side on this. Is your method already accredited in your laboratory? And also, have you participated in any reference independent comparisons to really have some evidence about the reliability of the results?
So the first thing before going for an accreditation to get your analyte accredited or brought into the scope of your laboratory, the first thing that you need to do is that you need to validate the method that you are using. So this falls under the class of similar to pesticides. So this the method of analysis has been validated using the SANTE 12682 2019 guidelines. So after validation, then the laboratory has got accredited for under ISO 17025 for this analyte. And we have participated in 2 proficiency testings conducted by the European Union Referral Laboratory.
And that's great. Proficiency testings are good evidence that actually the methods are valid, are comparable, and they can give reliable results. We know that the issue started with sesame, and you mentioned earlier in the introduction that it has been detected in other commodities as well. Is your method now validated to cover various spices? Are you working on expanding your commodities as well?
Yeah. Our scope of accreditation, we have validated this for not only the sesame seeds, but also for spices and herbs as well. So, and covers a broader spectrum of matrices.
That's good. So you can cover quite a few different cases, possible risk scenarios. So,
and I should also mention that the limit of quantification is 0.01 milligram kg.
Which complies, and in fact, it's really sensitive and much lower than other regulatory requirements, which is always good. We know now that exports need to have mandatory testing for ethylene oxide presence, and also that we know that spice and dry commodities have a quite complex supply chain. From your point of view, which parts of the supply chains you would consider as high risk, and is there any recommendation you can give in terms of testing points during the process?
I think in order to really understand from where the ethylene oxide contamination is coming in the product, so the monitoring should happen at various stages of handling, storage, and transportation, because it's very difficult to, without this monitoring, it's very difficult to say at which stage this is coming. If you see studies, there are studies, if you see that, you can see that there are cases where very low, I can say very close to the MRL detections of ethylene oxide would be there. But if you think about that, I would say that it is not an intentional contamination of the product with ethylene oxide, but perhaps it could be due to some cross-contamination. Now, one possibility is that maybe the packaging material, like the jute bags that are used for storing the products, may have been previously sterilized using ethylene oxide. So that's why it's very important that these areas need to be monitored.
Yes, it's always a fit-for-purpose risk assessment, really, is required. We focus quite a lot on ethylene oxide, and this is a topic of the moment, and it's great that you were able to respond quickly by developing this capability. I'm sure the laboratory has a wider range of scopes and can support with other contaminants and pesticides analysis. Would you just be able to briefly give us a bit of indication of other areas that you can work in this in the pesticides?
Currently, my laboratories are able to test more than 950 pesticides. And apart from that, we do the complete spectrum of mycotoxins and quite a lot of antibiotics, veterinary drugs, illegal dyes. So a broad list of all these contaminants and toxics. Now we are also able to move into targeted and non-targeted screening of pesticides and other antibiotics and veterinary drugs as well.
That's really good, and I assume that your scope is always increasing based on the current demand and any regulatory changes. Dr. Abraham, thank you very much for the information. I'm sure we can pick up questions offline and respond to everyone who has sent us a question under the comment section of the webcast. Thank you very much, everyone, for joining today. I hope you found this event very informative, and don't hesitate to ask any questions using the chat facility. Thank you very much.
Thank you very much.